Hello. So we are doing course 3 grade 8 and we are doing a challenging problem on dilation, similarity and translation. This is to prepare you for the upcoming test and I'm not going in detail with the basics, but when needed we can explain, and also please text me if you have any difficulty. I can go back again to the basics. So this is a question. Triangle ABC has vertices A, B, and C as given. And we have to dilate triangle by using a center of dilation, which is not 0, 0 as usual. It is 1, 1. Okay. And a scale factor of K 1.5 to create a triangle A dash, B dash, and C dash. Now, in the second step, we have to prove if the triangle ABC is similar to triangle A dash, B dash, and C dash. Now, if we translate A dash, B dash, C dash triangle to 3 units left and 2 units down, and it gives us triangle A dash, B dash, A double dash, B double dash, C double dash. So is it similar to triangle, original triangle ABC? So try this question on your own and then you can see the solution. So here, unlike the previous questions we did in the class, here the center of dilation is 1, 1, not 0, 0. So we cannot directly multiply to the scale factor k. So what we have to do, like these are the points. This is 2, 4. Okay, and the center of dilation is 1, 1. So we have to find this distance and then multiply it by 1.5. So how we'll do algebraically, we'll subtract center of dilation from the point xy. So we are doing it general. It is easier because then we apply whatever the formula we generate, we apply to all A, B, C, and we don't have to do it uh, separately all the time. Okay. So first we subtract center of dilation from point xy. So suppose this was xy. Okay, we can take it A, B, C, all the 3 points, and subtract x and y coordinates from this, which is center of dilation C. So x minus 1 and y minus 1 we get. Now we perform the dilation. We multiply it by factor of 1.5. So this gives like multiply whatever the points we got, the distance we got, we will multiply it by 1.5. So now we performed the dilation. Now we perform the dilation for this length, not for the length from 0 as we used to do when the dilation was 0. Now we have to add the center of dilation back to the dilated points. So these are the points we got after dilation. Now we'll add center of dilation again, which was 1 and 1. So this point we got, we subtract 1, 1 again. So we see that this we got it as 1.5x minus 0.5 and 1.5 y minus 0.5. So now this formula we can apply to A, B, C. We could have done put the A value here and got uh, A dash in this process, but then we have to do that again for B and C. So this we have generated a formula which would use 1.5 dilation when the center of dilation is 1, 1, 1. Okay, so it will be applicable for A, B, and C both. So for A, if I do 2, 4, just put x as 2 and y as 4 in this formula, and we get A dash 2.5 and 5.5. Now try getting B and C with the same formula. I can show you at the end with the diagram how it is correct and we can prove it with the diagram. So B64, again using this formula which we developed, which will give us dilation by factor of 1.5 when the center of dilation is 1, 1. We got this as a B dash. Now try getting C dash. So C dash we get as a 5.5 and 11.5. So if we see this diagram here, we can see this is the center center of dilation, and we can see that A dash B dash C dash is 1.5 times ABC, and it is dilated when the center of dilation is not 0, 0, but O, which is 1, 1 here as shown. Okay. Now let's try to do the third part, and please try to do on your own and then you can see the solution. So in the third part, it is required that the triangle is translated 3 units left and 2 units down. So please write an algebraic statement for this. So it will is 3 units left means x minus 3 and 2 units down is y minus 2. Now let's get A double dash, B double dash and C double dash. Sorry, the second question was prove that triangle A dash B dash C dash is similar to ABC. Now to prove that triangles A dash B dash C is similar to triangle ABC, we found the length of AB and A dash B dash. Here it is here simple because it is horizontal, so we found length of AB as 4, A dash B dash as 6, and the ratio of A dash B dash over AB is 3 by 2. Now for the lengths of BC and B dash C dash, we have to use the distance formula. So we find the length of BC as 2 root 5 and B dash C dash as 3 root 5 using this formula. So the ratio of B dash C dash over BC is 3 root 5 over 2 root 5, which is 3 by 2. Okay. Now to find the length of AC and A dash C dash, we use the coordinates we got here, okay, and the formula. So the length of B dash AC is 2 root 5 and A dash C dash is 3 root 5. So the length, the ratio is 3 by 2. I have not written down the coordinates here separately, but these are the same one we got here. Okay, these were the coordinates of A, B, and C, and these were the coordinates of A dash, B dash, A dash, B dash, and C dash. So I got the lengths using this formula, and we see that the ratio of all the three lengths corresponding sides are same, are proportional because, and all the corresponding sides are proportional because the ratio of corresponding sides are same. So the triangles are similar. That's why ABC triangle is similar to A dash, B dash, C dash. Now try the third part and then you can check the solution. So this is A dash, B dash, C dash is transformed to A double dash, B double dash, C double dash. 3 units left means X will change to X minus 3 and 2 units down means Y will change to Y minus 2 like this. So we got the A coordinates of A dash, B dash and C dash and we subtract x coordinates by 3 and y coordinates by 2. So these are the coordinates of A double dash on negative 0.5, 3.5, B double dash 5.5 and 3.5, and C double dash 2.5 and 9.5. So a lengths of AB Now we have to prove if this triangle which we got A double dash, B double dash, C double dash is similar to ABC, the original triangle. Okay, so we'll compare it with the lengths of the original triangle. So we know length of AB and BC. AB is 4 and A double dash double dash we can get it using the coordinates and this formula which we got 6. So the ratio of, and similarly we get BC which we already got to root 5. Now using this formula we got B length of B double dash C double dash is 3 root 5, and then length of AC we already got 2 root 5 and A double dash C double dash is 3 root 5. Now we find the ratio of A double dash over AB, which is 3 by 2. So we find the ratios of corresponding length of triangle A double dash, B double dash, C double dash, and ABC of the corresponding lengths. And as we put the lengths equal in ratios, we find that they have the same ratio 3 by 2. So if the ratio of the corresponding lengths is same, it means both of these triangles are similar. Okay. So the translation is a rigid motion that changes position but does not change size or shape. So we can see here if we put the coordinates how A dash is moved 3 units left and 2 units down, and these three figures are still similar. So please continue practicing and please let me know if you need help with any other questions. Wish you all the best for the test. Thank you.